engineer at OpenX, and I'm here to tell you a little bit about sort of how I introduced Erlang to OpenX and how we use it in a large portion of our production stack. So first of all, I'm sure not many of you actually know what OpenX is. Well, historically, OpenX was a PHP ad server, which sort of is interesting considering the last talk was all about PHP and sort of optimizing it, and this talk is going to be more about how we sort of moved away from PHP. And this ad server actually went back quite a bit. It actually was released originally as open source in 1998. It went through many different name changes. It was called PHP Ads, Open Ads, and eventually in 2007 a company was formed called OpenX, and it was rebranded as sort of OpenX Source, OpenX Community. And so that brings us to now what OpenX is today, which is a global company. We offer a software as a service enterprise ad server with an embedded ad exchange. And our system is written largely in Erlang. And for those of you who don't know the sort of modern internet advertising space, there's kind of two different types of advertising that occurs, or two different types of ads that are shown on pages. There's ads that publishers are able to sell directly to advertisers, and those are usually served by your ad server. And then there are ads which they don't have a buyer for until right when they're showing the ad at the time. And those go into these ad exchanges where a lot of sort of bidding happens, and the ad is chosen at the sort of last possible moment and placed on the page. So the first thing I'd like to do actually is sort of walk through our architecture over time and kind of show how it's changed. And then I'll talk a little bit about sort of, why I think we were able to make the transition. So as I mentioned, the ad server was originally written in 1998. So it was really a sort of Web 1.0 style system. You had a PHP system that delivered the ads, talking to a MySQL database. You had a PHP management system that helped publishers maintain different ads, insert them into the system. And so I sort of am representing this here with a few different boxes, and I've got a kind of legend on the side that talks about the languages that these are implemented in. So this was fine, and it was good up until about 2007. The company started running, software as a service, and so what happened is they just sort of took the open source ad server, started running it on EC2 on a bunch of instances, and sort of went from there, started signing up clients. And then in 2008, they decided to add in this idea of an exchange, because they said, well, we do good in the case where they are selling directly to these advertisers, but people have a lot of unsold slots on their pages. The bottom of the comment section, they want to put an ad there, but no advertiser wants to pay directly for that. So they really want to get integrated into these marketplaces. And this is really where you're going to make a lot of money, is actually running one of these marketplaces. So we really need to get into that business. Since the company was still located in the UK at that point, and its development was all being done in Poland by a team of PHP developers, well, the first version of the market ended up being like a PHP system that sort of sat next to the ad server. They communicated via some links at the client side, and this was fine. It worked for a little bit. Around the same time, a CEO was hired in California. He decided to move the company headquarters to Pasadena. They started bringing on some local development staff, and one of the first things they thought of, hey, we're enterprise now. We really need to look into sort of better data, better reports, and so Hadoop was actually integrated into the system. Postgres came about because for whatever reason in developing the market, they decided, well, we need another database. And they even made such great choices as, we're actually going to write to this database every single request that comes in, every ad request. Not just once, like 2 or 3 times, just because. So this really was also working for a little bit, but the company was still beginning, so they didn't have a lot of business. It was okay. I actually joined the company in 2009, and really the push in 2009 was like, okay, we really need to start scaling this thing up because we're just really not able to do what we want to do. So one of the first things I did was start investigating the NoSQL space, because as I had learned at Yahoo before OpenX, calling a relational database every request really starts to run into some scalability problems, mostly because you're usually doing a lot of joins, or you're doing a lot of work that's unnecessary. And really what you usually have is, if you can pre-can all your queries, you can just kind of look them up once. And so after looking around at the space, I sort of settled on Cassandra, It had sort of recently been open sourced from Facebook and seemed to do sort of the things we needed it to do. Also, since the market had been, this mess of object-oriented PHP that was, I kid you not, just incredibly awful. One of our guys who was a Java guy, he started rewriting it in Java. We also took the old ad server and kind of ripped it apart, pulled all the sort of HTTP specific part into a gateway and turned our ad selection into its own little system also written in Java. And this sort of gave us a little bit of headroom. So what happened is that we were actually able to scale pretty well. We were able to add new clients without too much trouble. But there was a new type of thing in the world, and it was called real-time bidding. So we had this marketplace, and people could sort of insert rules in order to decide when they wanted to bid, but you had a lot of more sophisticated advertisers who actually wanted to bid at the second that someone was looking at the ad. They wanted to actually know, oh, okay, I can figure out who this person is, and I think that they're worth this much, so I want to bid immediately. And I had some experience with Erlang, and I was like, I think this is a really good fit for Erlang, because what I have to do here is basically I'm going to have one request, I'm going to have to fan it out into a bunch of external calls to different services, and keep track of how long they're taking and give them their, I think 80 milliseconds is what we gave them when it first started, and I need to then return to upstream. So around, I think, December of 2009, I actually went and sort of prototyped and put together an RTB system, and we launched it in January and then fixed some issues, and around February we actually had that, and it was really successful. So that actually led to some other Erlang systems coming on board, because I had this experience. I had spent a lot of time sort of pointing out all the cool things that I was doing to the guy next to me writing Java, and he was always like, oh man, I'd really love to try that language. That sounds really cool. So we had another problem we needed to solve, which was keeping track of frequencies. So frequencies are sort of how often someone views an ad. And you could keep these in a lot of different things, but we really felt that a custom data store would be necessary, because just the scale of it made that a requirement. So we designed a C database that would sort of keep these things really efficiently in memory. And then we were looking to scale this across multiple machines. And at first, my colleague was looking into like 0MQ and some other things and thinking of doing it all in C. And I'm like, well, Erlang really excels at that, and it's really easy to sort of integrate. Maybe you should try it out. And surreptitiously, at the same time, we came across a post about React Core. And it had just come out, and it looked like it was actually a perfect fit. So we integrated React Core with this C database and created this frequency server that allows us to scale up to like, easily 100, 120 machines, keep track of all these counts of different things. And currently those things keep, hundreds of millions of keys, probably on the order of billions of keys in that system. This also sort of, around 2010, we also started to run into problems with Cassandra, in that they decided that they were going to make a non-backward compatible upgrade, which in our case would have required us to essentially shut down our business in order to upgrade, and that was really a sort of no-go. So instead of sort of trying to figure out ways around that, I decided to reinvestigate where things were in the NoSQL space, because I figured it's just as hard to like re-implement with a different backend than it is to try to figure out how to get around this upgrade path. And since we just had a lot of experience with React Core, I actually looked into React and actually developed a system that used React and some more Erlang in front of it to manage another part of our user data. And so you sort of see a little bit of more Erlang coming into the system. Well, in 2011, we actually decided to do a major rewrite and release our sort of OpenX 3 system. The biggest component actually was down in our UI layer, which got split into two pieces. It became a little more Web 2.0 UI API. They unfortunately decided to make the API in PHP again, and the UI was like JavaScript, HTML. But as we sort of started to rebuild more parts of delivery, and we now had some Erlang experience on board, we just started getting rid of all the systems that were PHP, and even some of the systems in Java, and re-implementing them in Erlang. And so we ended up with the gateway, which is our sort of how people access this being written in Erlang, as well as our marketplace. And an interesting note here is that sort of our ad selection piece and our market piece both have a problem of actually selecting ads. They just look at different pools of things. And in order to do this, we actually designed a DSL, and then we implemented the DSL in both Java and Erlang, and sort of can use them in either language. Yeah, and then also our monitoring system, which before had been mostly Perl, started to have a little bit of Erlang sort of coming in. And we still had Cassandra, which was unfortunate because we still were unable to move forward. And so we started planning on how do we actually move off of it. And the way that we went about that is to design this data service layer, which actually provided an abstraction above the database itself. You know, when we had first integrated with Cassandra, it was pretty much, you know, we were early on, we were just trying to get things working. So it was like, hey, Cassandra supports Thrift, we'll just call Thrift directly to Cassandra. Well, that was a bad choice. It made it really hard because in the end, you know, we had all this code in our clients directly calling our data source. So what we had to do is sort of build a layer in between. And so we built these different data services that represented our different sort of constituents. You know, one dealt with publisher data, one advertiser data, and one, the biggest one, actually, the user data. And I sort of actually did the user data piece, and it actually ended up being really nice because once I had converted the front ends to call the user data, which was calling the Cassandra system, I then was able to actually have it call both Cassandra and React. I was able to do dual writes for a period of time. Then I was able to, and I even got it so that I could take the data from both and sort of merge the results and send it out. And so I was able to sort of provide a seamless migration path away from Cassandra in that case. The publisher advertiser sides, they weren't quite as clean, and they mostly sort of just decided to, since the Cassandra pieces were actually being pulled from MySQL, which the UI was using, they were just going directly to the MySQL system. At this point also, since they decided that, okay, PHP for the API was actually a bad choice, we need to move to something else. So they decided on Python. But in order to sort of be able to switch between the different versions, we needed a router. And we actually had, since we had a lot to do, we actually had Erlang Solutions write that for us. And so far, it's been working great. Which brings us now to sort of where we are currently, which is, well, we've mostly migrated off of Cassandra. There's still a little bit there, but it's pretty much gone. The UI, one thing I forgot to mention is, so the UI goes through the router and into the API, and then the API actually talks to RabbitMQ, and then we have a system that reads out of RabbitMQ and writes it into React. And then we actually use React's multi-colo data replication to replicate the data out to all our serving colos, where it's then read out into our sort of publish and advertiser services. So while there's, you know, a little bit of Python embedded there in the center and some JavaScript and HTML at the top end, it's really a lot of Erlang, all in that pipeline. So, you know, where did that leave us in our architecture? Well, we have about, you know, 14, 15 services in Erlang. There was a whole bunch of other sort of more minor services that I didn't mention. There's actually a whole bunch of other services that are written in Java. And they're all pretty much pure Java. You know, Scala and Clojure have not quite taken over. Although there is a little bit of work being investigating Kafka, so I think that's Scala, I believe. You know, we also have some HTML, JavaScript, Python, PHP, things like that. So now the, you know, real question is, you know, how did this happen? You know, how do you take a bunch of PHP developers and turn them over to Erlang? And the quick answer is, well, we didn't, because essentially we laid off all the PHP developers once production moved to the US. To be fair, we kept one. We have one guy, but he moved to the United States. So, so actually, this is more a bigger question of, you know, how do you take people who don't know a functional language and actually sort of, you know, prepare them to use it or have a organization which you can use it. And so I sort of came up with about 3 things that I think allowed this. The first was sort of architecture. Now, some of the architecture was actually determined before I got there, and that was sort of this idea that OpenX was going to be very cloud-based. I mean, this is kind of, you know, standard these days, where it's cheaper to basically get some instances in EC2 when you're starting out than to buy machines. But they did a good job of getting into EC2, figuring out the tools in order to sort of automatically manage deploy systems. Sort of decided that okay, we're going to actually make sure that everything is packaged and that the things that we're putting on these systems are all prepackaged. None of this check out the source on the system. Focus on fault tolerance and being able to kind of run clusters of systems. When I came in, the next thing was sort of also, sort of standard these days was, well, okay, we need this to really be service-based. We're going to have a lot of small pieces, loosely coupled. They're mostly going to be single-purpose components. If we need to scale, we're going to have pools of these components. And then ideally, these components can be written in whatever language happens to work for the problem that component is trying to solve. So in order to do this, well, you need some tools that are going to allow you to kind of build systems in this way. So the biggest tool was really these sort of cross-language communication protocols that exist nowadays. And since we were playing around with Cassandra and it was using Thrift, we looked at Thrift and we said, hey, that looks pretty cool. It seems to work. It seems to do what we needed to do to talk component to component. It supported 12 or 14 languages at the time, including Erlang, as I noted in my head when we decided this before using Erlang. And so we should try out that. Protobufs came into play when we started doing RTB because the only other RTB player was Google. They were using protobufs to talk to people. If you want to go and actually integrate with those same people, well, if you can just copy what Google's doing, great. So we just looked at their protobuf and we made one that was pretty similar, and that made transitions for people a lot better. A third system we used was one I actually had developed it in 1998 at goto.com and was eventually open sourced by Yahoo in about 2008, and that's called LWES. It's a UDP-based sort of fire and forget protocol, so it's really good for sort of logging data and monitoring. And this is actually how we get all of our things from all of our different components into Hadoop, is we fire off these messages, collect them all, and then load them onto the grid. The other thing that I think really helped is having some way to build packages using different languages with a sort of common sort of tool chain. So there's a piece of software some friends of mine developed, and I helped out a lot with, called Framework. And that's not a misspelling. If you actually Google Framework with an E, you'll find something called FW templates, and that's what it is. So what this is it actually provides templates for code layout. It kind of lays out packages, and you sort of give it a language template, and it lays things out in a way so that you can then run the same commands. Make package will sort of make a build the code and then make an RPM or a deb if you're on a Debian system. Make test will run tests. It also integrated with our version control systems in order to sort of tag packages and really helped to make it such that packages were built in a reproducible way. It was easy to go back and figure out exactly which version of the software went into a particular RPM on a system. And the output of this was RPMs, which I think is really important to have some way. RPM provides a really nice way to sort of roll code out and then roll it back if there's a problem and manage dependencies. So it also works with on Debian systems with debs, and underneath is built mostly on auto tools, so it's a little esoteric and old school. But and the final thing was really evangelism. So really you need someone who's going to be there to sort of say, help people out. And like I said, one of the really big things is if possible, when you're making those architecture decisions and discussing things, if you can sort of stack the deck in your favor or fix it, that works. When I was there and said yeah, service-based, it's worked for us in the past, it's really good, and yeah, we should use one of these multi-language protocols, knowing that would allow me to try out new things without sort of requiring too many changes elsewhere. Finding a project that really showcases the technology. The RTB system, was a problem that really just fit with Erlang. It was very successful. We were able to get a lot of business from it. Making sure that project succeeds, it's a little harder, but it just means you have to kind of be prepared to take a little risk professionally in trying these things out. Making sure to share the work. I can't stress this enough. If you're basically the only guy who's sitting there working on some cool functional programming stuff, and you got other guys sitting around you, whenever you come up with some like very nice little compact solution to something, turn around and show them. Because half the time what would happen is the guy's jaw would drop and he would be like, man, that would be like 300 lines of Java. How did you manage to do it in like 10? And then you go and walk them through it, and then they're like, oh, wow, that's really neat. I really need to try that. And then again, making it easy for others to follow in your footstep, which again brings you back to tools. So we'd sort of had some of these tools that allowed us to do things. What I ended up doing is sort of customizing these tools to work with Erlang. So adding new templates to framework meant that people who were already building things with framework could easily build Erlang code. So that removed one of the steps, which I think I still see anytime I try to look at any kind of new language. Just figuring out a build chain and how to get it to a final production thing, it's very difficult. And usually it takes someone to actually sit there and think about it. So with framework, I tried to just basically create some templates that just in the end would pop out an RPM. And so that was great because that sort of got all the source and everything together, but next it came running it. And we actually, at a previous company I'd worked at, had developed some tools that allowed us to run sort of Erlang nodes and load code into them using the package manager. So upgrading an RPM would do hot code loading in the running Erlang VM. And so there were 3 tools that were part of that: ErlRC, ErlStart, and ErlNode. These are all open source, by the way, framework and these ErlRC tools. This made it easy for people to sort of run Erlang nodes, try out their code. So it was all about sort of removing the barriers to adoption, making sure that people could come and pick up these things. We did have some challenges. Hiring people is almost impossible. I think we found one person who knew Erlang before we hired them. But really what you have to do is just look for good people and then train them in-house, be prepared to train. For operations, well, they've got unfamiliar systems. They're not going to know it. There's going to be a little bit more hand-holding. As a developer, you're going to have to be more a DevOps role where you sort of train them. Developers are going to have lots of new concepts, and you have to be prepared to actually help them get through those concepts. And often you're doing new things, so be prepared for problems. So how did Erlang help OpenX developers? Well, these fit our service model. The language fits the service model really well. It's concurrency. Let it crash means things would crash. We wouldn't even notice. I'd notice in the logs weeks later, oh, this thing has been crashing every so often. No one's really noticing. I'll go fix this bug and it'll stop crashing. The VM scales really well across multiple cores. And also the functional aspects lead to a lot of easier to test and read code. And how did this really help OpenX? Well, OpenX, and these numbers are of about late 2012, was doing 250 billion monthly ad transactions. So all of those going through many Erlang systems. About 12 billion plus bids going through our RTB systems. We have thousands of machines, and we've got right now about 300 employees, and in 2012 we had 150 million plus in revenue. So I think Erlang has helped OpenX a lot, and it's been great sort of getting it in place there and teaching people to use it. And I think now we've probably got a dozen folks who actually use Erlang daily. Great. Any questions? Mm-hmm.
How do you, so when you, it sounds like your system is very sort of heavily service-based. How do you make a decision between, say, putting something in a library versus a service? Or actually that's the other way around as well. Do you have a sort of framework thinking about that? Or?
Okay, so the question was, with the service-based solution that we've come across, when do you decide to put something into a library versus put something into a service? And I'd like to say our services are probably not as fine-grained that we've had to make that decision too much. For the most part, anything that I think, I don't know, usually on the Erlang side, it's anything that basically is like maybe a module or two and doesn't really have to keep a lot of state, or maybe is like a very small application that does a very small thing. I'll just release that as a library Erlang application. But for the most part, there aren't actually too many small libraries that are shared between the different pieces because they all do kind of their own little thing in their own little way. The big thing that's shared usually is the protocols between them, so the thrift files and the thrift bindings, and then a little bit of config data, which usually is better serviced as a library because everyone really needs to get the config anyway. So, so yeah, we haven't had to, we're not sort of at the micro scale that we have that many services running around. Well, it looks like a lot. They actually all are relatively large. Almost every service probably, at minimum, I'd say a lot of them have like 100 machines.
One more question. I was intrigued by your framework because it seems to tackle a lot of the really boring problems such as RPM integration and so on.
Mm-hmm.
So also the fact that it's other tools based just means it's probably very, very portable despite being esoteric.
Yep.
Is this something we should be leaping on from other languages such as Camel and Haskell and so on to?
I would frankly love to see it. Unfortunately, it's a little ill-documented at the moment, although you can pretty much look at any of the other templates and sort of figure it out. If you're interested in porting it to other ones, I'd love to see it more used. I found it sort of invaluable in sort of just easily creating RPMs and debs because essentially you can, it's much easier to hand someone an RPM than it is to basically even give them source code. So if you feel like it, come chat with me and I'll give you more info. Great, thanks.